4C is going to span a few pages, but we're looking at a reaction here, carbon monoxide with water to make CO2 and hydrogen. It gives us a temperature. And remember, although we won't use the temperature in the calculation, change, like each K is unique to a specific temperature. If we make it hotter or colder, that does change the value of K, although adding and removing things will not. So the constant's 5.1, slightly more products than reactants. Calculate the equilibrium concentrations, 1 mole of each thing. So that means they're all 1 molar. 1, 1, 1, 1. That is not our equilibrium value. Those are our initial values. We need to think about our change. And on 4.2, we just looked at these. We need to think about which thing's going away and which is being made. Nothing is 0. So we have to think about what we know. What we do know is that K is slightly greater than 1. That means at equilibrium, we have a higher ratio of products to reactants. And since we know that everything's starting exactly the same, 1, 1, 1, 1, that to have more products than reactants, we would have to create CO2 and hydrogen. We would have to consume these. That's how we know that this is a plus or a minus. If it's not something we can do by really quick look or inspection, there are ways. We can use Q, and we'll do that in the last example here. But now I know, relatively speaking, that these are 1 minus X and 1 plus X. That allows me to then come down to my K expression. I plug everything in. Because the coefficients of everything are 1, I don't have any exponents. And on this one, even though it would be a fairly complex one, since it's the same thing on the top and on the bottom, or 2 of the same on the top and 2 of the same on the bottom, excuse me, it's really 1 plus X squared, 1 minus X squared. So that allows us to take what could be really ugly algebra and simplify it. Everything here is squared, or it is a perfect square. I take the square root of this number, it's 2.26, take the square root, take the square root. That eliminates those squareds, so now the math is a lot easier to do. I distribute over, I combine my terms, I find out what my X is, and my X is slightly below 0.4, so 0.387. The value with the rice table let us know, first of all, what is being made and what is being consumed, but then what's important is sometimes after all of this math, we think that X is a final answer. Remember that we have to subtract on our reactants and add on our products that amount to know what our final molarities are. If you ever are not trusting yourself or need to check that again to make sure that you have added and subtracted correctly and that it's making sense, you plug these right back into their spots. So this squared on top, that squared on the bottom, and making sure that that comes out to the value you want it to.